form is our a plus bi. So in that, I can't be on the denominator. To get it off the denominator, it's kind of like when you get a radical off the bottom. If I have like 2 over the square root of 3, we would multiply top and bottom by the square root of 3. So if I have 3 over I, I'm going to take the top and bottom times I. So when I do that, the top it becomes 3i, the bottom becomes I squared. But what is I squared equal to? So 3i divided by negative 1 is negative 3i. All right, so for B, if I have 3 plus 2i over 5 minus I. Okay. So you said multiply by 5 minus I. If I do that on the bottom, what would you have to do to multiply this? FOIL. So you would get 25 minus 5i minus 5i plus I squared. Did my i's cancel out? No. How would I make it so that these i's in the middle would cancel? Yeah, we have to do the conjugate, which is the same thing but opposite signs. So if I multiply by 5 plus I, the bottom becomes 25 plus 5i minus 5i minus I squared. The top you FOIL as well. So you get 15 plus 3i plus 10i plus 2i squared. So if we combine like terms, that's 13i. Positive 2i squared is like 2 times negative 1, so we get negative 2. On the bottom, these cancel out, so you have 25 minus I squared, so minus negative 1 would be plus 1. So I get 13 plus 13i over 26. Technically, is this in standard form? A plus bi, a real number plus an imaginary number? The top is, but the whole thing is over a fraction. So to be true standard form, we have to break it up and put each one over the denominator. What does 13 over 26 reduce to? Plus 13i over 26 would be 1/2 I. So on those fractions, you do need to go ahead and break them apart and put each one over the denominator and reduce. Could you guys try a couple of these? Here are yours. What do we have to multiply the first one by? By I. If you did 9i, you're not going to be wrong. You just have to reduce later on. But since it's single term, all we need is the I. So that would give us 5i over 9i squared. 9i squared is negative 9, or you could write that as like negative 5/9 I, so it looks more like your traditional standard form. Either one is fine. B, the denominator has 2 terms, so what do we have to multiply by? Conjugate. It's the conjugate of the bottom, so 4 minus 3i. You have to FOIL, so on top you get 16 minus 12i minus 12i plus 9i squared. On the bottom, you get 16 minus 12i and plus 12i, or you might have already recognized those would cancel. Minus 9i squared. Negative 12i, negative 12i is negative 24i. 9i squared is negative 9. These cancel. Negative 9i squared is positive 9. So, combining like terms, 16 minus 9 is 7, minus 24i. 16 plus 9 is 25. Is that standard form though? No, you have to break it apart. So, 7 over 25 minus 24 over 25i. And that would be our final answer. No, it's not. It's why you should work it out instead of just looking at it and writing down an answer. An important lesson to be learned here.
Right.
All right, do we need more of these?
No.
Okay. We are going to see these imaginary numbers when we start solving quadratic equations. They come up in the quadratic formula. So I just want to make sure you know how to take an expression like this and write it in a plus bi form. So negative 8 plus the square root of negative 128 over 4. What would I have to do first here? Okay. The square root of negative 128, we could take out an I. Are there any perfect squares that go into 128?
64.
Okay, so we get negative 8 plus the square root of 64 is 8. We have an I, radical 2 over 4. Then we just divide each thing by 4. So negative 8 divided by 4 is negative 2. Plus 8 divided by 4 is 2i radical 2.
See, I did that one.
Good. Everybody can try B now. We'll see if we get that one right. All right, so the negative 200, because there's a negative under the radical, we take out an I. You can break 200 into 102. Square root of 100 is 10, so that's 10i radical 2 over 5. So if you divide 10 divided by 5 is 2, plus you also have to divide this one by 5, so 2i radical 2. All right, looks like we did pretty well with this. Any questions there? The final thing I want to talk about today is powers of I. Okay, so we know I is the square root of negative 1. What is I squared equal to? What if I said I to the third? That's the same thing as saying I squared times I. I squared is negative 1 times I gives us negative I. If you have I to the fourth, that's the same thing as saying I squared times I squared. So negative 1 times negative 1 is 1. What happens if I said I to the fifth? You could think of this as I times I squared times I squared. So I times negative 1 times negative 1, and we just get I. We're back to the beginning, right? So I to the 6th would be negative 1. I to the 7th would be negative I to the 8th would be 1. So we should be able to simplify any power of I. And you can only get 4 possible answers. 1 or negative 1, I or negative I, if we reduce them. So let's take a look at some. And we are going to try to rewrite these. So if I gave you I to the 15th power. Now we could write out our pattern 15 times, but that's kind of annoying. Make sure you're paying attention. So we know that every time we get 2 i's, it turns into negative 1. So my question is, if I have 15, how many groups of 2 can you make? 7. 7 times 2 is 14, so there is 1 left. Okay, so I rewrote this in terms of I squareds. That's 14 plus 1 is 15, so that's all of them. We know I squared is negative 1. If you take a negative to an odd power, what do you get? Negative. So negative 1 times I. On these, There are only 4 possible answers. I would require work. So I know how you got your answer and that you're not just blindly guessing. I know, it is painful to write this out. But I need to at least see this first expression so I know how you got to your final answer. So if I said I to the 33rd power, how would we rewrite that? So, right, 2 times 16 is 32, we need 33, so there's one more I left. I squared is negative 1. What happens if you take a negative to an even power? If I have an even number of negatives. Type it in your calculator, put negative 1 in parentheses. It's a positive. Yeah, your parentheses. So if you're using your calculator, you have to put it in parentheses. An odd number of negatives stays negative. An even number of negatives becomes positive. So this one just gives me I. If I said I to the 22nd, how would we rewrite that?
I squared to the 11.
I squared is negative 1. If you have negative 1 11 times, is your answer positive or negative?
Negative.
If I said I to the 12th, how many groups of 2 can we make?
6.
And there's none left over because 2 times 6 is 12, so I squared is negative 1 to the 6th. The negative to an even power is positive 1. All right. Any questions there? So what I want you to do right now is finish that Math Excel assignment from yesterday. I might take some, in about 20 minutes I might do one more thing.